Hi, I'm Kirsten. Welcome to Real World Science. Light is a very important part of our everyday lives, and it is the focus of this Real World Science program. What is light? When you think about light, what comes to mind? Light bulbs? Fire? The sun? Well, those are all sources of light, but do you know what light is? Simply put, light is energy that you can see. On a sunny day, not only can you see light, but you can feel the heat it gives off too. Want to know why? Come on, I'll show you. You already know that light is energy. So how does that energy get from the light source to you? Well, light travels in the form of a wave. The wave is actually a disturbance created by the transfer of energy. We can demonstrate that. If you look at the surface of this lake, the water appears fairly smooth. Watch what happens when a stone hits the water. When the energy from the stone is transferred to the water, waves are formed. If you could see a light wave, it would look something like this. Notice how it goes up and down. This type of wave is called a transverse wave. Light waves are unique because they don't require a medium in order to travel. A medium is any solid like the ground, liquid like water, or a gas like air. That's why, even though space is a vacuum with no air, you can see light from stars that are thousands of miles away.
So we know that waves kind of look like ripples in water. So electromagnetic waves travel about 300,000 kilometers per second. Remember, a kilometer is the longest version of a meter, which we sometimes compare to a mile, but it's not quite as long as a mile. Electromagnetic waves travel about 300,000 kilometers per second. This speed is faster than anything else in the universe. In fact, it's impossible for matter to travel this fast. Remember, matter would be like a solid object or a liquid. It cannot travel that fast. Although the sun is 150 million kilometers away, light energy from the sun takes only about 8 minutes to get to Earth. Light from the sun and other stars travel through space. Unlike sound waves and water waves, electromagnetic waves do not need matter to travel. So remember, we talked about how the different light energies can either pass through our atmosphere or not. So they're traveling from the sun, and it only takes 8 minutes for those light waves to get all the way down to Earth. That is very fast. Light from the sun and other stars travels through space, and that's how we can see them, because the light is actually traveling from space. So all of the light you see outside right now is actually 8 minutes old. It left the sun 8 minutes ago, and now it's just now arriving at Earth.
Properties of light. Let's examine some properties of light waves by looking at a graphic of a wave. Waves go up and down with high points called crests and low points called troughs. The first property we are going to discuss is amplitude. We can measure amplitude by measuring the height of a wave, the distance between the center of the wave, and the crest or the trough. Another property of a light wave is wavelength. Wavelength is determined by measuring the distance between two high points or two low points on a wave. Frequency is another property of light waves. This is a measurement of the number of waves that pass a certain point in a given time period. Frequency is a very important property of light waves because it is one of the properties that set light waves apart from the other kinds of waves. The frequency of a light wave determines where it appears on something called the electromagnetic spectrum. Let me explain further. Light waves are a special kind of waves called electromagnetic waves. Electromagnetic waves transfer electric and magnetic energy, and those waves are part of something called the electromagnetic spectrum. That's the name for the range of electromagnetic waves in order of frequency. All electromagnetic waves travel at the same speed, but have different wavelengths and frequencies. The electromagnetic spectrum is made up of radio waves, infrared rays, visible light, ultraviolet rays, X-rays, and gamma rays. As you can see, light waves fall somewhere in the middle of the spectrum.
Remember, those are the only ones we can see.
The fact that you can see light waves is very important. That's one way they are different from all the other electromagnetic waves. They are visible. Before we go any further, let's take a moment to review what you have learned so far. You know that light is actually a visible form of energy, and that light travels in waves called transverse waves. Those waves have special properties that include wavelength, amplitude, and frequency. You also learn that light waves don't require a medium in order to travel, and you learn that light is part of the electromagnetic spectrum.
Light travels in straight lines away from its source, but it can change as it travels. For example, it can spread out as it travels. This spreading out makes a light source look dimmer as you move away from it. Light will change speed and direction when it travels from one type of matter to another. This change is called refraction. For example, light slows down when it moves from air into the water. This causes the light to bend. Reflection is a light bouncing or reflecting off objects. Why can you see yourself in a mirror? Light from your face is reflecting off the mirror. Diffraction spreads out the light waves. An example of diffraction is water vapor in the air refracting light from the sun to create a rainbow. All objects, even a mirror, will absorb some light. When light is absorbed, it changes from another form of energy, such as heat. So that's something, all of those things are things that you can do at home just to explore. You can get a mirror out and use like the flashlight on your phone or use a regular flashlight and see if you can angle your phone, and it should leave a little bit of light on the wall or something. Sometimes my cats like to jump up on those little spots from my phone and the light reflecting off of them. So it's really neat to know that light actually reflects off of different objects, which is how you can see different things in the different colors. If I look at a house, it's not producing its own light. It's actually just having light from the sun reflect off of it, and it shows a certain color to me. I think that's something that's very interesting. All right, the last thing we're going to do today is look at these transverse wave models. Analyze the three waveforms shown, then select the options to complete the statement comparing the waveforms. So we have three sentences down here. We got to figure out the blanks. So if I'm just analyzing them before I even look at the questions, I have A, which has, it looks like probably 2 wavelengths as the frequency. We have 1, 2, this one has the same amount, and so does this one. So, but notice that B is shorter, so the frequency is shorter. So in A, the amplitude is greater because the amplitude is from the crest into the middle. The amplitude is in the middle, and we can measure down to the trough as well. So this is a little bit longer than this one, which we can kind of think as tall. So B is the tallest, then A, then C. And then we can also look at how the wavelengths change distance. So we have C from crest to crest is longer than B from crest to crest. So let's go ahead and look. The distance between the crests of the waves, which is what we were just talking about, is greater in wave C than in wave Yeah, B. If we look at A and C, the wavelengths are actually the same length. They're spreading out the exact same distance. So B is our answer for that first question. The next one says wave A has a longer wavelength than blank. So the wavelength is measured from crest to crest. So is that longer, this gap, is it longer in B or C? Sorry, is A longer than B or C? Yeah, it's longer than B. Again. And the last question, the distance between the crest and the trough is higher in wave A than in, so the distance between the crest and the trough. The crest is the tip at the top, and the trough is down here at the bottom. So which one has a greater distance right here from top to bottom than, let's see, the distance between the crest and trough is higher in A than what? So which one's shorter than A? Yeah, C. And we'll check our work, and that'll be it for the day. See if we got it right. Good work, everybody. I'll talk to you on Friday. I mean on Monday.